received a package today in the mail. Let's open it up and see what's in it. A little way bill. Use that for shipping it back. This came from one of my YouTube viewers. I reuse this box, so I don't want to damage it. Oh, look what we have here. We have a nice old JVC VCR, 4-head VCR. Looks like he bought it at the Goodwill store. And apparently it has a problem, and that is what we're going to work on today. We're going to pop the top off this thing too, just do a quick visual inspection before we actually get into it. And the back pops off. This is an old but good unit. This one features a linear power supply, not a switching power supply. As you can see, good old conventional transformer, linear voltage regulator. Now we'll power this unit up and just see what it does. We have a time display, but the unit will not power on. Press the power button, nothing happens. So the first thing we're going to look at is we're going to look at the power supply, make sure there's no broken solder connections or anything on the regulator, make sure that the linear regulator I see here is in fact working. See whether we can get this unit to power up. So one of the first things we're going to do is we're going to check the fuses, make sure none of the fuses are blown. There's two fuses located over here on the power supply. I'm just going to measure them with a continuity tester. And they both measure good. So we know it's not a fuse that's blown. Next thing I'm going to do is I'm going to give the unit a good look over and look for any bad solder connections that may have broken. And then we're going to check for all of our supply voltages coming off the power supply. Make sure that we've got our standby voltages and our constant supply voltages. On a VCR there's two voltages. There's our constant supply, which powers up the system control and powers up the clock, etc. And then there's the switch power supply. The switching is done, and it's not, I'm not talking switch power supply as in a switching power supply like a chopper type circuit. I'm just talking the power switch, and that's all done through this STK, or is it STR? STK5481 voltage regulator. This is a linear voltage regulator that controls the power to the main circuit. So I just spent a few minutes looking at the power supply on this thing. I resoldered the main regulator, but what I have noticed is when I press the power button, I'm now getting motors coming on. I have no power light. But it's definitely trying to do something. Grab the tape and see whether I can load a tape up and just see what it does. Well, it threaded the tape and then it proceeded to unthread the tape. I did not hear the drum motor start up. So let's just quickly open up the main board here and take a look underneath the main board. See exactly what's going on. I think we are missing a voltage. Is what the problem is. So our drum's not spinning. So I think our problem is we're missing a voltage. But it certainly appears that we're not getting our drum voltage. Maybe our switch 12. I'm going to just pop the bottom off the unit and just take a look underneath and see what we can spot. Remove this plastic screw and the rubber feet, and the bottom will lift off. Okay, what we have on this unit, we have a loading motor, we have a direct drive reel motor, we have a direct drive capstan motor, and we have our drum motor here. Okay, it looks like we found the problem on this machine. I was hoping it wasn't going to be the regulator, but it's looking like it's the regulator that's bad. Got the data sheet for the regulator showing that the power control is going into pin 5. So I got my meter on pin 5, and when I press the power button, you'll see that the voltage goes to 6 volts. And turn the power off, it goes to 0. Pin 5 controls the switched output for VO number 3, which is pin 4. So we go to pin number 4. We got 0.7 volts, press the power button. Nothing happens. We're not getting a 12 volt output on pin 4. That's our motor supply voltage. Pin 9 is one of the, so I can get here. It's hard to see the pins here, but anyway, we have no output from this thing. This regulator is not working. I'm just going to look at the inputs on here as well. Pin 8 is an input. I have 23 volts on that. That's one input. And the other input is pin number 2. Any input on number 2? Oh, pin 2 does not have any input. Interesting. Oh yeah, it does. There it is, 12 volts. So we have an input on pin 2, and we have an input on pin 8. We have our control power on pin 5, and our switching is not happening. Our output are pin 9. That's one 12 volt regulator, that's always on. Another output on this thing here is pin 6. We have 12 volt output, that's an always on output. And we have another output on pin 3. So okay, so what I've done now is I've bypassed the switch. So this wire is just connecting the 12 volt supply from, what is it here, pin 3, no, sorry, pin 8, which is output, which is the 12 volt output, and I've got it connecting to a pin 4, which is the switched. So in theory, when I turn on the power here, we should have power on this unit. We won't be able to turn it on and off, it will just come on. And it does, we have power. Can't turn it on and off because this is hardwired on. Let's just see though whether this actually will work. Because if this is all that's wrong with this machine, this unit should, in theory, work. Play. And voila, we have a picture. Okay, we're back on the JVC. I've got the part came in today, so we're just going to remove the regulator assembly here, remove the screws, and we're going to replace the failed regulator IC, the regulator assembly, and remove the board here. And we're just going to have to unsolder the IC and remove it, and put some heatsink compound, which I have here. It's just to drain the heat away so that it won't overheat. And so we're just going to unsolder this old IC and get the new one ready to go. Now, of course, before we just start, let's just make sure that the new one that has arrived is the same part. STK 5481, and it's an STK 5481. So we do have the correct part here. Always like to check that because this just arrived in the mail today. So we're going to use some solder wick to remove the old IC here. There are many ways to remove solder. You can also use a vacuum pump. I've used those before too. I don't have one now. I used to use one of those all the time. I had a manually operated pump, but it was one of the things that I got rid of when I got out of the repair business, because I thought I would never use it again, and didn't hang on to it. Okay, now we can turn the board over here and undo the screws. Probably the easiest way to actually take this thing out, because it's a very tight fit, is we'll remove these screws here on the bottom and actually remove the whole heatsink with the IC still attached to it. So we remove the screws and then the entire heatsink will just pull out like that. Now I can remove the screws and discard the old regulator IC. Just stick a screwdriver down underneath the corner here and just pry up to pop the old IC off, and you'll see what remains of the old heatsink compound, which is all dried out. So we want to try and scrape off that old dried compound so we can get some new heatsink compound in here. So here's our new heat transfer compound. We'll just stir it up a bit here. So we're just going to smear some of this stuff on, try and get an even coat on here and on the back of the IC. Smear this out on the back as well. Try and get a nice even coat of heatsink compound. What this stuff does is it's got silicone in it. It's a silicone based grease, and what it does is it allows the heat to evenly transfer. It fills the gaps because you're never going to get a perfectly flat fit between the metal heatsink and the component itself. So what this does is this just fills any gaps and allows the heat to transfer through it. It's got it's a silicone based grease, but it's got small particles of metal in it that conduct heat very well. So we're just going to tighten this down. To ensure a good heat transfer from one surface to the other. You don't want to over tighten these screws because you will strip them. They are just into aluminum and they will strip if you over tighten them. And now we just have to remount the IC in the circuit board here, line up all the holes. There we go. All the pins have poked through the holes. We'll just put the two screws back in here to attach the heatsink to the board, and then we can proceed to solder the new IC back into place and test the unit. I think I said this before, but this unit is actually going to be shipped back to Seattle where it came from. This came from one of my YouTube viewers who picked this unit up and it didn't work. And it's a good machine. He needed this machine. He wanted this machine repaired. I contacted him with what parts was needed, and he was able to source the parts and sent me the parts. So Once this is fixed up, we'll be shipping this thing back and this unit will be put back in service. There, they all look good. Nice and shiny. Now we can proceed to reinstall the board. There's a plug. Now we've reinstalled the board. There's a plug down here that you have to make sure your alignment is correct. For that plug, it's a dual set of pins. Now we can put the screws back in to hold the transformer and the power supply heat sink in place, and the unit should be ready for testing. Power on. We have a light. Tape goes in. Play. There we go, it's playing. There's our tracking control on this thing. Somewhere in here there should be a tracking control. Where is it? There we go. It is fixed. The bar in the picture, that's just the shutter on the camera. It's a rolling shutter on this camera, so it has a tendency to do that when you film a screen. But there you go. There's a repair of this JVC HRD180, and the problem with it is it was this STK5481 voltage regulator. Now what we're going to do on this thing before I finish off this video is I'm going to clean the heads, because it's probably been sitting around for a while and it's going to need the heads cleaned. So I just removed the screws here. We're going to open up the board, access the heads on this unit. Okay, looking down into the top of this machine, first of all you can see that the chassis is completely all metal. We've got multiple motors in this one. We've got a motor to load the tape. There's another motor that loads and unloads the tape, threads and unthreads the tape. It's underneath the deck. We have a motor here for the head drum. We have another motor here that controls, it's a direct drive motor. You can see that. It's a direct drive motor for the capstan. And there's another motor underneath here. It drives this rubber tire for fast forward or rewind, but it's another direct drive motor. So you get a reel motor, a capstan motor, a drum motor, a loading motor, and a cassette loading motor. 5 motors. This makes this one of the better of the VHS machines, and why this machine was one of the few machines that's actually worth fixing. A lot of them are not worth fixing, but when you get a machine like this, build quality on these is very good, and they have very few issues. So a machine like this is certainly worth putting a little bit of money into. Repair it. It's going to last for a good long time. Good quality components, made in Japan. These just were a great machine. The weak link on these was these ICs. These things went all the time. These were the biggest problem that I ever had on these were these STK5481 voltage regulators. So we got our isopropyl alcohol out. Just wet the Q-tip here. We'll use this to clean the capstan shaft and the audio control heads, which are the ones down here. So we'll clean the audio control head. And we'll clean the capstan shaft over here. Actually, it's not even that dirty compared to, well, considering how old this thing is. There's a little bit of dirt on here, but not a lot. And of course the pinch roller at the back here. Okay, I lied. There was a whole lot of dirt on that. Whoa. Okay, time to clean the head. You use just a piece of white paper. The best way to do this, just soak it with your alcohol. Just hold it up against the side of the head drum and turn. And as you can see, there was a little bit of dirt on there. Not a lot, but there was a little bit. In the picture, if I go to search, where's my search forward? There we go, search forward's working. Search reverse is working. Now you'll notice what happens on these machines. I'll take the camera off the stick so you can see this. Okay, as soon as I press the stop button, you'll notice that the tape is going to unload. You can see how the tape is threaded there. I press stop, and it immediately unloads. And then the head drum stops. If I go into rewind or fast forward, the tape actually rewinds, fully retracted into the cassette. So if I want to go back into play and I press the play button, it has to stop and it has to rethread the tape. One other thing we're going to do on this unit before we send it out is I'm going to lubricate the chassis, because this grease down here has a tendency to get sticky. This black grease has a tendency to get sticky. So we're going to wipe this grease out. We're going to put in some of the newer molybdenum grease so that this machine will be good for a good long time. So we'll just wipe the grease out here. I've still got some alcohol on this Q-tip, which will dissolve the grease off quite nicely. So let's get some of the moly coat grease, put it on the screwdriver here. You don't need to put much of the stuff in. Once it thins out, once it spreads a coat on here on the metal parts, it's really slippery stuff. We don't need to use a lot of it. A little bit on each side. As they say, too much grease is often worse than not enough, because it'll eventually attract dirt, and dirt will cause things to stick. So we're just going to put a little bit of grease on these metal rails, and they will work in to the guide posts as the tape threads and unthreads. So we'll just put the tape back in here again. Hit play. And there we go. Tape is playing. We should probably make a recording on this, so we'll just take out this tape and I'll put a tape in that I can record on and get a source to record. Okay, I've plugged it into my home cable system. Play and record together on this thing to put it into record, and I'm just going to record my in-home aquarium channel. This is my very exotic saltwater aquarium that I've got set up. And back in the day when my aquarium was at it, the same fish are still there, but things changed over the years, right? I made this recording when my aquarium was in what I would have called its showcase state, when I had a lot of live corals that were growing really nicely, and it was really clean. The fish are much older now. These things live forever. Some of these fish in this tank now are about 9 years old. This was done a couple of years ago, and when it was at its really nice looking state, I made a nice video and turned it into a loop, and I just leave it playing on one of my cable channels that I created in my home network that I've talked about before. And it's nice because I can just go to any TV in the house, turn it on to channel 49, and I've got music coming off of a satellite dish, so I can just turn it on, look at the fish, and listen to music anytime I want. And this is just playing off of this is playing off a Raspberry Pi. I think actually this is playing off a BlackBerry Playbook. If you remember the old BlackBerry Playbook tablet, and I've got the HDMI output connected into an HDMI to composite converter, and that takes the output from the BlackBerry Playbook and converts it down to standard definition for modulating. So I've got my Playbook running, just playing this video as in a loop, and it works great for that. So we just made a quick recording here. I'm going to do recording on both speeds. So there's the SP speed I've just been recording, and we'll just turn this down to the EP speed now, and make sure that everything's working as it should. So we'll stop it, go back into play, and rewind the tape. Go. I gotta press stop. I'm still on record. Stop. There we go. Now I can rewind it. Okay, and here's our playback. SP speed, and it'll switch to the EP speed in a second here. And there it goes to the EP speed. So this unit is working. So just going to pack the unit back in the box it was shipped to me in. And little corner pieces and everything here to protect it. This is a really nice box. Should keep this thing nice and safe on its way back home. Now I know what you're thinking. What actually is inside one of these ICs? Can we open this up? I say we probably can. Let's just see whether we can pop this thing apart. See what actually goes on inside it, because I know they open up relatively easily. There's the guts to the IC. So basically what we have inside here, if you're looking, is we've got some transistors and some resistors. And not a lot else. Okay, these parts here, get something to point with. These are transistors. That's what a transistor looks like when you remove its case. It's got 4 large transistors here, which are being used as voltage regulators. Got some driver transistors down here, a little capacitor here. I think it's a capacitor, maybe it's a resistor. Some jumper wires, as you can see. And these are probably the Zener diode references down here. Or no, those are transistors too. You can see, you can tell it's a transistor because it's got 3 leads on it. Right? You can actually see, where am I here? My screwdriver. You can see the little wires going into it. So that's a transistor, that's a transistor. That looks like a diode. That's probably a Zener diode, reference voltage diode. And see if we can get a little tighter here with the camera without it going out of focus. I don't know how close I can get. I guess I'm in all the way. So there you go. So here we have a couple transistors here. There'd be resistors underneath here too, right? This is like a thick film. These are probably resistors underneath this black on here, but there's transistors, transistor there, a transistor there, a transistor there. That looks to be, could be a capacitor. That almost looks like that connection is fractured. I wonder if that was the problem with it. Look at this. This capacitor here almost looks like the solder connection has failed. Maybe not. It just kind of looks kind of funny there where it's soldered down. But another transistor here, another one over here. So transistor here, transistor here. There's a jumper here. Another that's a transistor. That's a transistor, that's a transistor, that's a diode. It's only got 1 lead going to it. And here are the output, these are the regulator transistors. So one of these transistors here is more than likely what's gone wrong with this. That's what's caused this to fail, is one of these transistors inside this IC. Anyway, I just figured I'd show you guys what the inside of a module looks like. If we were to pop apart any of those STK or STR modules used in a lot of the amplifiers, they look very similar inside. They have more circuitry obviously in them because they're not just being used as a voltage regulator, they're being used as an amplifier module, but they look very, very similar to this inside. This is how an integrated circuit module is assembled on all these little leads here. These are just spot welded down. They're not soldered. These are spot welded down to the board. Interesting, no? If we look at this thing close enough, we might even be able to see what went wrong with it. I mean, really, the problem with this was it wouldn't turn on and off. So one of these pins, I forget which one it was, controls the power in and out. See, on this transistor here, you're able to identify emitter, collector, and base. The collector is the going to be the case here, and that's connected right down to this pin 2, and this collector here is connected down to pin 4, right? And then the emitter and base would be these lines here. One's the base and one's the emitter, and this is the actual silicon chip right there. That's the silicon chip, the die as they call it. Hope you enjoyed this video, and we'll catch you in the next one.